So the last category is exponential functions basic solving. So we're going to solve them. Okay, a town, or let me screenshot this first. A town has a population of 4,000 and grows at 2% every year. To the nearest year, how long will it be until the population reaches, or until the population will reach 6,400? So remember, we still have, this formula. So they're asking us how long it will be. That means we're going to search for the t, okay? So we're searching for the t. That means we should have every single other letter. So the town has a population of 4,000. That's your S. 1 plus or minus. Well, it is growing, so it's a plus. It's a 2% every year. So let's take the 2%. There's a decimal right over here. We're going to move it 2 to the left, which becomes 0.02. And so this is our R. And then we raise it to the power of t. Remember, we don't know what t is yet. And they want us to figure out how long it will be until the population will reach 6,400. So this is our setup. Remember that we have all the other letters. The only letter we do not have is t because we are searching for the time. We want to figure out how long it will be. So we don't know this yet, but we will figure it out. Before I do that, are there any questions? Let's keep going. I'm just going to rewrite this over here so that I have space to solve. Oh man, I should have written smaller. Okay, I squeeze it in, it fits. Okay, so essentially this is our equation that we are solving now. I'm just going to zoom it in so it's bigger so you can see. And let's simplify it a little bit. I'm just going to simplify this part. 1 plus 0.02, that's just 1.02 to the power of t. So all I did was just add up the stuff inside the parentheses, so it's a little bit more simple for us. So we've done problems like this before where we are solving for the exponents, so we're going to have to use a log. But before we can use a log, we must get our exponential by itself. And so this part that I just boxed in, this is the exponential piece. It's the base and the exponent. This is the part that we want to get by itself. So to do that, I'm going to divide both sides by 4,000. That way, those can cancel out, and we can be left with the 1.02 to the power of t all by itself. And then on the left side, we just have that fraction. Hopefully, this is starting to look a little bit familiar when we just get our exponential by itself. Now, we can do a log of both sides. So I'm literally just going to write log of both sides. Okay, I'm going to pause here and see if there are any questions up to this point. All right, so now that we've done that, remember that the exponent that happens to be in a log, you can actually bring that into the front. So that t as the exponent, now it becomes t in the front multiplied by log of 1.02. And of course, this left side doesn't change at all. So I'm just going to write it out. So nothing changed on the left side. On the right side, the exponent got moved to the front. So it's now t times log 1.02. Zoom out just a little bit so I have more space. And last but not least, if we want t by itself, t is being multiplied to log 1.02. So we want to get rid of the log 1.02 by dividing by log of 1.02. So divide by log of 1.02. That way, those can cancel out and we will be left with t. And on the left side, we will just have that fraction. So log of 6,400 over 4,000 divided by log of 1.02. And so this is what I will be typing into the calculator. But before I do that, are there any questions? And let's type this in to the calculator. So functions log 6,400 divided by 4,000 divided by another log of 1.02. Okay, and we want to the nearest year, so that means the whole number. So 23.7, that's going to round to 24. Okay, any questions on this part? Okay, let's do another. So the same basic idea, we have this formula. And let's read the situation so we know what to plug in where. So it says an element with a mass of 540 grams decays by 17.9% per minute. To the nearest minute, how long will it be until there are 90 grams of the element remaining? Okay, so let's start plugging stuff in. An element with a mass of 540 grams, so that's our starting amount. And then we have 1 plus or minus. Well, it says decays, which means we're going to be decreasing, which means I want to write a minus sign. So decaying means decreasing, so minus sign. Our R is going to be given to us by 17.9%. So then we're going to take the decimal and move it 1, 2 to the left, which becomes 0.179 as our R. And then to the nearest minute, how long will it be? We don't know what T is because that's what we're looking for. How long will it be until there are 90 grams of the element remaining? So that is what we set it equal to. So I'm going to rewrite that on the right side so that I have space to write out my problem. I'm going to write it smaller so that I can actually fit it. So 90 is equal to 540, the starting amount, parentheses 1 minus because we are decreasing. Then here is our percent as a decimal to the power of t, our unknown. We don't know what t is yet. Let's keep going. I'm going to zoom in over here so that you can actually see me do work. Okay, let's simplify that part. What is 1 minus 0.179? I'm just going to use my calculator on my phone. 1 minus 0.179 is 0.821. So all I did was simplify the inside of the parentheses. And so this is what we have. So remember, it's the same basic idea. You want to get your exponential by itself, so that's the part that I'm boxing. If we want to get that by itself, we need to get rid of the 540. So I'm going to divide everything by 540. That way the 540s will cancel out, and we get 0.821 to the power of t is equal to 90 over 540. All right, so now that we have our exponential by itself, that means we can take the log of both sides. So I'm going to write log of both sides. Log of 90 over 540 is equal to log of 0.821 to the power of t. So log of both sides. Now with the t as our exponent, we can move it to the front. So that t is the exponent now becomes t in the front multiplied to log of 0.821. And then the left side doesn't change. Okay, before I go on, I'm going to pause the video, see if you guys need any time. Okay, so now we have t multiplied to log of 0.821. So we want to get rid of the log of 0.821. So we're going to divide by it. Log of 0.821. That way, multiplying by log of 0.821 will cancel out. Will divide. will cancel out by the dividing of log of 0.821. There. Does that work? Okay, so from here, like we said, they will cancel out. It will equal t. And then what will I type on the calculator? It will just be that entire thing. Log of 90 divided by 540 divided by log of 0.821. So this is what I will type onto the calculator. Whoa, that's not what I wanted to do. That's what I wanted to do. Okay, log of 90 divided by 540 divided by log of, what was it, 0.821? Yeah, okay. And we want to round it to the nearest minute, so nearest whole number. So it's 9.08. Our nearest whole number is just straight up 9. And then that's it. So I'm going to go ahead and submit this. And let's do maybe 2 more examples. Of course, if you don't need any more examples, feel free to just work on the problems that you have. But I'm just doing 2 more examples for anyone else that happens to need it. So remember, our basic formula is the same. So a new car is purchased for $15,100. The value of the car depreciates at 12.25% per year. To the nearest year, how long will it be until the value of the car is $2,300? Okay, so let's plug things in that we know. A new car is purchased for $15,100. That is your starting amount. And then 1 plus or minus. So the value of the car depreciates because most of the time, if you buy a car, the value will go down. So you want to subtract at 12.25% per year. So let me write that out as a percentage. Now we're going to change it to a decimal by moving it 2 to the left. This becomes 0.1225. Okay, and then we're raising it to the power of t. Remember, we do not know what t is. We are solving for t. So t remains as the variable t. It is our unknown. We want to figure out to the nearest year, how long will it be until the value of the car is $2,300? So that's what our P is. Let me rewrite this over here. Oh my gosh. Okay, I'm going to rewrite that again. I need more space. Okay. I'm going to write it small, and then I will zoom in later. Okay, there we go. I fit it. Okay, let's solve this. So I'm going to simplify this part. So let me rewrite the other numbers. Okay, so what is 1 minus 1 minus 0.1225? That would be 0.8775, the power of t. Okay, so that part's there. Now let's get our exponential by itself. Remember, this is our exponential. So I need to get rid of the 15,100 in the front. Get rid of the 15,100 so that they'll cancel out. And then we're left with this fraction over here. Okay, so now our exponential is by itself, which means we can do a log of both sides. All right, so here's a log of both sides. Now, once you do the log of both sides, that t as your exponent can be moved to the front. So I'm going to put it as a t in the front instead of as the exponent now. So t times log of 0.8775 is equal to log of, this part doesn't change. Okay, so let's zoom out a little bit so we have more space. Okay, so t is multiplied to log of 0.8775, and we want to get rid of the log of 0.8775. So therefore, we must divide both sides by log of 0.8775. That way, they will cancel out, and we will be left with t. And then on the left side, I just have to write that entire thing out now. And this is what I will type into our calculator. But before I go ahead and type it in, I'll pause the video, see if you guys need any more time. Let's type all of that in. Log of 2300 over 15100 divided by log of, what was it, 0.8775. I believe that is correct. Let me just look at what I typed. Yes, okay. How long will it be to the nearest year? Well, it says 14.4, and so 4 is a small number, so you're going to keep it as 14 because we want it to the nearest year, which means nearest whole number. So just 14, and I will submit answer. Let's do one more together. And of course, if you don't need these examples, I'm literally just doing these for the people who need it. Okay, I'm going to use a different one because we just did a car example. Cool, another population. Let's do this. Remember, no matter if it's population or car or elements or bacteria, whatever it is, we have the same basic formula. This formula. So we will have a town with a population of 8,000. And then it's growing, so I'm going to do 1 plus. Remember, growing is increasing, so you want the plus sign. And it's 3% every year. Oops, I kind of accidentally wrote it. My brain jumped ahead. Okay, 3%. Here is your decimal. You're going to move it 1, 2 to the left. So it becomes 0.03. Okay, and then it's raised to the power of t because once again, we don't know what t is yet. We're going to solve to the nearest tenth of a year. So we don't know what it is. It's going to stay unknown. How long will it be until the population will reach 16,300? So here's our setup, and I'm going to rewrite it over on the top. Okay, I'm going to rewrite it again because I have this habit of not writing small enough. Okay. Zoom in over here so that you can actually see. Let's simplify. What am I simplifying? This part, 1.03. Okay, so once again, same basic idea. Get your exponential by itself. And in order to do that, we're going to divide by 8,000 so that they cancel out. So once they cancel out, you will be left with your exponential by itself, which is exactly what we wanted. Now that your exponential is by itself, we can do the log of both sides. So I'm going to write log and then log on this side as well. Now remember, once you log the exponential, the exponent can be moved to the front. And then this side just doesn't change. Okay, so now that our exponent moved to the front, we have t multiplied by log of 1.03. To get rid of the log of 1.03, we're going to divide. So that they cancel out and you're left with t. And on the left side, we will have this giant mess of a fraction. So let me write it all out. There we go. And this, that was a really ugly box, but this is what I will type into the calculator. Now, before I go ahead and type that in, are there any questions? I'm going to go ahead and type it into the calculator now. So log of 16,300 divided by 8,000 divided by log of 1.03. And we want it to the nearest tenth of a year, so it's 24.1. It's a 0.1 because technically on here it says 0.07, and remember to the nearest tenth, so we're looking at the 7. 7 is big, so I'm going to round the 0 up to a 1, so it's 24.1. Okay, and that's it for this category as well. And this was our last category, so that's it for today's lesson.